So now we're going to learn about the uniform probability distribution. It's a little bit of a mouthful. And that's what that looks like here. And here's the first slide talking about it. And I'm just going to grab this one here and bring it over also so we can see it on the first slide. And I'll put it right there. And that will allow us to check it out while we talk about this. All right, so this first sentence, the way it describes it, it's a little bit wonky, but it says a random variable is uniformly distributed whenever the probability is proportional to the interval's length. So again, we're looking at the probability of a random variable falling within an interval's length. And if we were to increase this interval's length, the amount we increase is going to be proportional to the interval's length, right? So if we double this, the probability is going to double. If we triple it, the probability that it's in that length is going to triple, because the probability is all even. So the more we add proportionally, the more we add to our interval proportionally, the more our probability is going to go up. That's not true with these. If I was to increase this interval by increasing it a little bit to the left, we're going to add like that much, which is a larger amount than if I increased it a little bit to the right, and we'd only add this little amount because it's on a curve. It's not like evenly distributed, right? The probability is not just like this linear box. It's got a curve to it. And so that curve, right, is not an even distribution of the probability. So it's not a uniform distribution of the probability. So a random variable is uniformly distributed whenever the probability is proportional to the interval's length. The uniform probability, that's again like, why is statistics need to make things more complicated than they are? And then the uniform probability density function is 1 over b minus a. For a, where the value you're looking for, x, the random variable x, is like greater than a, but it's less than b. So if we're looking from 120 to 140, our a is 120, our b is 140. And like if these are flight times in minutes between two locations, so that means our x has to be somewhere in here, right? Like the entire sample space of flight times from these two, from one location to another, is only 120 to 140. Anything outside of this, the probability is 0, right? 0 elsewhere. And so we're looking for like things 120 to 140. My a is 120, my b is 140. X has to fall somewhere between that to use the probability function and get some probability. So if this is 120 to 140, there's 20 minutes there. So we have 140b minus 120a. That gives us 1 over 20. And so for each of these intervals, right, we're going to have a 1/20th probability for each interval. And you can see that being calculated here. So if we have, 140 minus 120 gives us 1 over 20. And if we want to know the probability of a flight time, some value being between, and we talk about values with continuous distributions, we talk about values falling within a range or an interval. So if we're looking for a value, like if our flight is between 120 and 130 minutes, we want to know what's the probability that our flight comes in between 120 and 130 minutes. Between 140 and 120, we've got 20 spaces, 1 over b minus a. That's the probability density function. Okay, there's the probability density function. And I'm just going to make that color to make it stand out. And then we take that probability density function and we multiply it by the number of minutes that we're looking at here, 10 minutes. And that gives us 0.5. So we have a 50% probability that our flight time will be between 120 and 130 minutes with a uniform probability distribution, which is what you see right there. So that's a uniform probability density function. To get the expected value, it's a plus b divided by 2. That's your mean. To get the variance, it's b minus a squared divided by 12. Why 12? I don't know. That's the PhD in statistics. And so here's the text of that little example of the flight time between Chicago and New York being between 120 and 140 minutes. And here's the uniform probability density function. And x is the flight time of an airplane traveling from Chicago to New York. And because this is continuous probability, we don't talk about the probability of random variable assuming a particular value, right? We talk about a probability of random variable assuming a value within a given interval. So we talk about this, right? Like the probability of, a variable coming in somewhere, the flight time of an airplane traveling from Chicago to New York, fx, right, being between some interval. And so that's how we talk about it. So expected value, variance, and then there's a little graph of it. And then here's flight time of an airplane, probability of a flight between 120 and 130 minutes. So that's how you work with a uniform probability density function. You just look up these formulas if you need the expected value and the variance. And you remember the uniform probability density function. We'll make that this thing here just to be consistent with our colors, is this. And then you just remember that, hey, it's going to be over an interval, and you figure out, what is the uniform probability density function, multiply it by that interval's length and the width, and you get the probability of the flight time being between 120 and 130 minutes. All right, that's uniform probability distribution.